Good evening, everyone. So it's a pleasure to be here today. So myself, Anand, Kumar, Ganesan, alongside I have Mohammad, Arif. So we both had a privilege to lead the product security team in Poshmark India Private Limited. So today we are here to cover the topic, what PCI means to the product security teams. So basically at the end of this session, you will get more insights about some of the regulations that was placed as a mandatory by PCI 4.0. So going ahead, so let's have some small introduction about PCI. PCI is a compliance that was formed by Visa, MasterCard and other financial institutions in the year of 2004. And during the same year, they have released its first version 1.0. And then it's a proactive approach. So basically, it was brought in as a preventive measure to improve the security and protection of the cardholders. So it was not only triggered by a single event, but it was an accumulation of payment frauds and then security failures and some of the data breaches that was happening across all the payment and financial systems. So in the rise of payment card frauds and data breaches like TJX and Heartland payment systems emphasize the need for PCI DSS. So hopefully we'll learn more about these data breaches in the upcoming slides.
Good. Let's remember about this TMAX breach, which had happened back in 2005-2006. So TMAX is a subsidiary American company for they basically sell the apparels and goods. And the most fascinating about this breach was extended for 2 years and it was unnoticed. And the attackers were able to exfiltrate 40 million plus credit card data. So this is huge. And also, they just not only affected the main company, they have affected all other subsidiaries of that particular company like Marshalls and TJX. So all the people who have been purchasing or shopping from their stores, basically they all got compromised. So think about it, you just went to buy a pretty shirt or pretty dress and ends up your credit card details being in the black market, right? And you never know how that data is being used. Further, that can be used for the fraudulent activity or cyber criminal activity. And one can never say that that money could also be used in some terrorist organization. So it's really impactful in the regulations, obviously. So basically, the attackers they attack on the WPP channel of a Wi-Fi. Although in 2004 it was defined that WPP is not secure enough, it has a lot of vulnerability. People have left that, but still, I don't know why TJX choose the WPP inscription, and once you choose such, then there is always a impact, right? So the same had happened with the Heartland payment system breach. It's an organization which deals with the payments, payroll services. So this was one of the massive breaches. 100 million of credit cards, credit and debit cards were exfiltrated by the attackers. This breach also had happened for 1 year, and again, the amazing part about it, it was unnoticed for 1 whole year. Then Visa and MasterCard saw that there are some fraudulent activities or some issues with the payments. Then they notified the Heartland payment system. Then on the further investigation, they found out that they were breached.
So after all these data breaches, PCI awake and they came up with some set of new controls. Basically, they had the revised version of all the regulations that they had previously, and then brought in the new version called as 1.2 in the year October. Sorry, in the month of October in 2008. So thereby, PCI started evolving. They started looking around the data breaches that is happening around the payment fraud trends that are happening across, and then they started coming up with new frameworks with new set of regulations. So likewise, in version 1.2, they have enforced the security, network security of an organization. So they have made some stronger encryption things, and then they started emphasizing on the monitoring part. So whereas like in 2.0, so with the 1.2 version, they had some they were not given more clarity on the requirements. So they have given some clear-cut requirements by consolidating some of the requirements. And in PCI 3.0, they came with continuous monitoring, security culture, and then some controls to third-party access. So in 3.1 version, so they have removed the support for the weaker or insecure protocols like SSL and some early versions of TLS. So that comes 3.2, where they started enforcing on MFA and then some detailed guidelines to the third-party vendors. So after implementing all these things, do you think that the attacks got stopped on the payment pages? No. So still 30% of the attacks were on the financial and payment pages. So there comes an important attack called as page card. So basically, they have made the biggest impact in the industry by skimming all the credit card details in the payment pages. So there was a famous airline called as British Airways, which was also impacted by this particular attack. So they have got a hefty fine of 20 million euros. And there comes Ticketmaster. So it was also got a fine of 1.25 million. So this is not a mistake by themselves. It is all about the JavaScript that they have included in their website, which has brought them a lot of fines. So while taking a step and then looking for either a single organization is being targeted from these attacks, definitely not. And attackers had a very bigger or broader mindset. So basically, they were targeting the service groups, which was used by a lot of organizations. So that actually brought in a huge impact here. The food ordering systems they have targeted, and that particular service was used by 300 restaurants, and everybody got impacted with that. So, and also likewise the e-commerce websites, 18 major e-commerce websites got affected by this particular attack. And there comes a special one, AC. So whereas they started targeting the individual vendors. So rather than going via groups, they also targeted BASI just by getting into their system and then writing a code according to what they have given, and then try to exfiltrate all the data out of it. So let's try to understand. So all these attacks got happened with the help of JavaScript there. So let's try to understand why JavaScript security is more important, and also how this attack got happened. So why JavaScript security is important? JavaScript by itself is nowadays have become a wider programming language that was used across most of them. And then around 94% of the websites use third-party JavaScripts. Why do they use third-party JavaScripts? Because they are dependent on ads, CDM, content, social medias, and then some sort of tag manager usages, and then some media types. Likewise, for all these purposes, they wanted a third-party JavaScript to be embedded into our website. So let's see, probably it is not a malware or a ransomware that was affecting and taking the data out of it. It is just one misconfigured JavaScript which is responsible for exfiltrating all the data from our website. So let us try and understand with an example how the JavaScript is actually being loaded in our website. So let's take an example from a browser. We are hitting our website. Say this is a website that is hosted by us, that is mysite.com, which is in the response sending an inline JavaScript to load a third-party JavaScript. The third-party domain in the usage is advendor.com, and then we are loading a JavaScript called as tracker.js. Now this particular domain will be called from the browser, and the JavaScript will be inserted, or it will come into an act in our browser. So we never know when the content of the JavaScript is going to change. We are not going to monitor because it is not at all coming into our picture. Say that it is not at all coming into our infrastructure to see whether the script got changed or not. So that is the major problem here, and also like we are not sure like what kind of data these JavaScripts are accessing from our browser. So these are all some of the important points that we have to look at it, and like you can see that Kohl's is one of the major e-commerce website in US, and in the home page itself you can see a lot of third-party JavaScripts being loaded. That emphasizes or that strongly tells how third-party JavaScripts are being used in the real world. So now let's pause here and then try to think from an attacker's perspective how we can broaden the impact of this particular vulnerability. Say that a third-party JavaScript is executing on our website, whereas like we don't have any control over it to stop somewhere. So here, from an attacker's perspective, like let's ensure to increase the attack vector. So how can we do that? So basically, like if you like target a particular organization, then the customers who are using that particular website will only be affected for this particular attack. But if you target any service providers, then that particular service provider will be invoked by a lot of organizations. That or every organization will have its own customers. At the end, you will have a lot of people who are being impacted for this particular attack. That is how an attacker actually maximizes this particular attack. So as an example, you can see that the CDN and third-party libraries, open source services, payment services, third-party advertising services. So these are all some of the services that are widely used and attackers targeted to maximize this particular attack and get it ongoing. So let us try to understand what is Mage Card. So the name, how they have came and arrival to this particular name is like the Magento is a platform that was hugely impacted by this particular attack, and it was a card and checkout provider, service provider for card and checkout, and they have like combined the Mage and Card and formed a name called as Mage Card groups. So usually whenever the skimming happens, they call them as Mage Card groups. So there are some examples. So in the first example, like an attacker is trying to target a hotel e-commerce service provider. That particular service is being used by a lot of hotel managements, and like whoever is using that particular website was getting the malicious JavaScript loaded into their system, and the data were accumulated and sent to the attacker server. So in the approach 2, they were targeting the third-party services, that is ad services. Ads is something that is like nowadays become a mandatory stuff for a website. So like many of them load the ad pages, and via ad pages they injected the third-party malicious JavaScripts, and that in turn collected all the data from the website and have given it to the attackers. So the basic ideology here is like inject the malicious JavaScript, capture all the data from the browser, and then send it to the attacker server. So that's the actual motto of this particular attack. But like this was there for a very long time, and attackers have exfiltrated so lot of payment card related information from it. Then actually like PCI awake, and then they came up with their own set of controls. Wherein like they started emphasizing on the JavaScripts, basically like in all the payment pages, whatever the JavaScripts that are being loaded, we have to authorize. Then we have to verify the integrity of the JavaScript. Then we should know what JavaScripts are being loaded in our payment pages, for which like we should develop an inventory of JavaScripts that are being loaded in the payment page.
Before moving ahead, just one point. So my friend said that 30% attack. So it's attack increased by 30%. So there have been attacks already going on, and we have seen in recent years there is an increase of 30% attacks on the payment related pages. And I think attackers find it really amazing to exploit these pages because they're gonna have. It's a direct equivalent to the money, right? Card data skimming, everything they're gonna sell in the black market. Then they can fish the user and get the money, right? Okay, coming back to the presentation. So, how can we how can we safeguard something which we don't know? So this is one of the biggest issue throughout the industry, that we do not have an inventory. And PCI came up with this, that boss, you need to have inventory. Because if you have inventory, then only you're gonna control, right, what's there. Second is authorization. Having inventory is not just enough. You need to ensure what is required, what are not. So in the polls example, we have seen a lot of third-party JavaScript, right? So some might be useful, some might not be. Some might be of the legacy code, which might not be serving its purpose right now. So why to have them there, right? And the third most important part is, there is a saying that they say that the one who is your worst enemy was at one time was your best friend, right? So this is a real life thing, that people changes, so do scripts also. Their behavior too. So you need to be. I think that is the reason why industry has come up with the zero trust policy. We should never trust anyone. Of course, in the context of software and web application, you can trust people in your personal life. But again, let's come back to this. So, right. So, what is our available option for working on these controls, right? So these are controls being specified by PCI. Now we have to do certain things about them so that we can give them a proof to be successful in the audit, right? So available option would be CSP is a content security policy. It's a browser-based It's a browser-based control. Another could be you can use a JavaScript agent which can load into your system and can further analyze what scripts are being loaded on your system, what not, and you can place a control. Then third could be a remote monitoring. So let's say you don't want to inject something on your page, you are very, you think it might ends up losing you. You might end up losing your performance of a website. So you might be thinking, let's go with another solution called remote monitoring. I will set up some third-party script which is going to monitor and tell me what's wrong happening with my website, if in case it's something is happening. So, in our organization, we went through a lot of discussion and we found out that CSP works for us best. Again, this is not recommendation, it's completely depend upon what is the goal of your organization and does it fits you better. But in most of the cases, CSP does. And the reason being that it's a built-in browser security, so it's very less likely to be bypassed. It's offer you real-time oversight, so you can use it in report-only code or enforce-only code and see the alerts. As I said, it has no impact on website, but that won't be a right thing. Again, it will have some minimal impact depending upon how you have configured the CSP. So, for example, if you have whitelisted, let's say 30-50 scripts, now that's gonna increase the cache amount of your header. Again, how you have configured your CDN to handle that cache will come in the picture how your application is able to handle that. So, CSP is not only applicable just to restrict or control the JavaScript, you can also apply it to the other resources like images, media, form. You can also control what data you want to send to some third party, whether you really want to send some data or restrict it. You can do all that with the CSP controls, and I think this is my best one, that it uses a whitelist approach. If you guys are security engineer or you work in the security industry, there is a saying that whitelists always have a upper hand over blacklist, right? Obvious reasons. Okay, I was when we were making this presentation, I saw this thing. I thought it's very relevant, so I kept it here. So basically, it's better to have something than nothing. No solution can be best. But you have to see from the standpoint of your organization what best fit in your bucket, and you have to choose it accordingly. So let's see how a CSP can help our organization. So we have a browser. Browser gonna load a website, and further we can see that on the website we have implemented a CSP policy. If you can see, I don't know. I hope it's visible. So we have put a content security policy with script SRC. We have whitelisted a domain ADTX vendor, and there is another directive which is connect SRC. So script SRC basically deals with whatever scripts being loaded on your website, and connect SRC deals with whatever information are being sent to a third party from your website. Now in the connect SRC we have defined cell. So it says that anything can be sent from your website to your domain only. It cannot be sent to the third domain because we have not whitelisted it. So let's take an example where website is loading a inline script called ADB Xvender, and it is loading a tracker.js. In initial days it was doing some performance thing on the website, but after some time it got hacked and compromised, and then it's trying to extract the user PII data. You can say that user card data for this intent, and then try to send it to the attacker control server, that is email.com. Now our content security policy will come in place, and it will say, okay, boss, you have defined connect SRC as a cell. Now you cannot send data to any third party, so I'm gonna stop this connection. So they will not allow send any data, and that's how you gonna protect such kind of attack.
Yeah, as Arif rightly said, so content security policy is a HTTP response header that will be appended with the sources that has to be whitelisted. It can be implemented in two ways. One is report only mode, another one is block mode. So report only mode, what does it mean is like say that like the domains that you have whitelisted. Other than that, if some domain is trying to load something, it will allow and send the report back to us. Whereas in the block mode, it will block the source which was loading apart from what we have whitelisted and then send the report. That's the basic difference. So why do we need a whitelist? Why do we need a report only? Is because to frame a CSP policy. So now like we are coming and starting with the CSP policy, whereas like it doesn't know like which domain is like loading what. So for this particular purpose, we use report only mode. We try to collect all the domains with some report URI like PRP using it, and we'll try to gather all the violations, and then we'll sit with the business team or like engineer team to see whether it's a legit domain that has to load in our website or not. Whatever the legit domains that are coming in, we will like add it to the CSP policy, we will enhance it, we will see that everything is working perfectly fine, and then we'll get into the block mode. So why it is so much necessary like to do all these steps before block mode is like, if you do any single thing wrong, your website may end up by impacting it. Say that like some legit script stops loading and functionality might break. So these are all some cautious steps that you have to develop, you have to be taking while developing the CSP policy. So some of the important CSP directives are default source. So it is a fallback directive. Say that like if you have defined a default source and there are some directives that you haven't mentioned, then that particular for missing those directives, you can have this default source as a fallback. And then script source. So whatever the domains that loads the JavaScript in your website, it has to be defined here. And then connect source, as Arif mentioned, that whatever the domain that is trying to collect the data from your website, you have to whitelist those domains here. And then frame source. So whatever the domains that has to be loaded in a frame in your website, you have to mention it here. And then frame ancestors. So this is like basically you are providing permission for external website to iframe your website. So that is what is frame ancestors, and report URI is basically a collector tool or collector domain, which will be like collecting all the violations from your browser and then it will be sending it. Okay, it's time to show some demo. So we'll try to like see how CSP can be implemented with all these directives. We have developed a sample application which includes all of directives in here, and also there are something called as inline JavaScripts and eval function. Basically, these are all something that are dangerous because it could stop, unsafe inline would stop some attacks like XSS, and eval is a function that can execute anything. So basically, these are all something that should be avoided when we are developing the CSP policy. But at times, our developers tend to develop it in that particular fashion, so that we tend to use those unsafe inline and unsafe eval. So here in this example, we have given all the sources and trying to load all the content. So first, we are trying to load it without any CSP policy. So you could see in the response header that CSP is empty, and we are trying to show how this application is functioning. Say that we are making a GitHub call, we are trying to execute an inline script. So likewise, for all the directives we have mentioned, and we are trying to load without the CSP policy. Now we will be applying a CSP policy, which is developed in a way that it will not impact any of this particular application's functionality, so that you can see the same thing after applying CSP. So we have applied the CSP. Yeah. Now, so in the inspect element, we will show you that the applied CSP policy. You could see that script source, default source, connect source, everything was defined, and we are trying to load all the sources, and the application was running without any issues or without any problem.
That red mark is warning. It's not. It's not something which is not being loaded. It's being loaded, but it's just doing the warning. It should not be doing that.
Yeah, in our CSP policy. So we have just included so that the usage of the web application will be smoother. Now we'll remove the unsafe inline and unsafe eval that we have used in the CSP policy and see how the application behaves. Because we have wrote the inline script, we have given the execution of an eval function. So we'll try to show you what will happen. So the revised CSP policy is applied now, and you could see the reports that are being triggered to because of the violations, unsafe inline and unsafe eval. So these are all the reports that are being triggered because of the CSP policy. Now it will not give the smoother UI like what we had previously. So that's why developing the CSP policy is a bit crucial. If you leave a single point, then probably it will hamper your application. It will hamper, none of the things are executing. So everything got stopped. So that's why we have to be very careful enough to develop and implement the CSP policy. Now we'll show another example wherein the example of exfiltrating the data basically to the attacker's domain. So here we are making an external API call to github.com, api.github.com, and then at the initial place it is loading perfectly fine. Now in the CSP policy, we'll remove that api.github.com and see whether the connection is established successfully. Now we have removed the api.github.com from the list. If we try to make this connection to api.github.com, we will get a CSP error saying that the domain which was not included in the trusted sources was getting blocked. Hope you might have now understand that if the importance of whitelisting the domains inside the connect source. Sorry.
So as we said, everything has pros and cons, right? So there are also challenges in implementing safety policy. The very first challenge is having a list of all the JS which is being loaded on the application. You might have a third-party JS which is being loaded on your application, right? And you might need it. That's a fair ask. But now that third-party JavaScript might be using eval function or inline function, right? So now that's an issue. When you remove the unsafe inline and unsafe eval, those scripts are not going to work. So you have to be cautious about it. And also, another thing is there could be a lot of JS script. Now, if you try to whitelist all of them, it's very difficult and it's going to impact the performance on a website. So for the companies like who are dealing with the payments, like for them it's very crucial the performance. You cannot, you cannot work on the delay part, right? You cannot work on something like somebody is trying to do payment but it's not happening. It's very frustrating, right? So that's one of the reasons why CSP is challenging part. Second thing, if let's say we are using a browser or a plugin, a compromised browser, I would say, so it will create a lot of noise. Now you will be collecting all the logs of the CSP, and when the person who is digesting that, he will become mad. There is a lot of violation. So he needs to go through all of them and find out what is legit, what is not. So that's another challenge with the CSP. It's iterating and time consuming. As in, like, for example, the CSP you are planning to put on your payment page might not be the same on the home page. In home page you might be loading extra 30-40 scripts. In payment page you might not be loading it. So CSP cannot be same. So you have to define a CSP policy according to the page itself. So that's going to take a lot of time. Inconsistent browser support, that's another challenge. For example, Internet Explorer, although people do not use it now, but Internet Explorer do not support CSP. So there could be users who might be using certain browsers, right? So it might not support a CSP. So that's again an issue. Again, just a small error can break your system. Not the system, but the page itself. So it's very. I am a victim of this. So in my last organization, we are dealing with. We have implemented CSP policy. Everything was working great, and then came the violation, and because of that, there was a downtime of 10 minutes. Maybe I iterated too much. It's not 10 minutes, but yeah, it was about that. So, but it's very crucial for a running business in the production. If you have such kind of violation, then it's gonna be difficult for you as well because they're gonna question first you have created a safety policy. Okay. Again, we discussed this point that increasing a length of CSP might lead to performance issues. Okay, this is a very important part. Like if your company is using pre-bit.js sort of script which loads a lot of advertisement data, then CSP might not be the best thing for you because the moment the script gonna change, you have to update the CSP policy. And pre-bit.js work in a manner where they bit, and the moment they bit, they're gonna insert a new JavaScript to load that particular advertisement. So in this way, CSP fails. Then again, this is I already discussed in the first point that a lot of people do not develop their own system. They tend to use third-party JavaScript to do some work around on their website to have certain functionality. Again, since you are not the one who has created it, you have no control over what is being written. And if you have written your CSP policy in a way that it's not compatible with that particular JavaScript, it's gonna break your application. So there is a IAB Tech Lab. So basically, it's an organization which deals with the legal support for advertisement organization. So they have created a safe frame sort of application. It's not a magic, just it's a iframe with some extra functionality. Also, it makes sure to restrict querying. The issue with the iframe is you can load website onto your iframe, but that cannot take data from the host or cannot set some value to the host. So, for example, some advertisement some advertisement script need an authenticated data in order to show you relevant ads. So if they are not able to set a cookie, they will not be able to show you relevant data. So for example, you are watching a website and there's you are a cybersecurity engineer and there is an advertisement team for HR role, right? It's frustrating. It will not be relevant to you. So that is the reason you need to in place some sort of authorization, would say, in order to collect relevant data, and these company can show you relevant advertisements. Again, so IAB frame helps in a way that it's allow you to collect data or set certain data on the host website that was not in the case of the previous, previous frame, iframes, and also you are not, they have also restriction in place that you cannot take all the data. So you can define what data you want to exfiltrate. So it's kind of safer approach than the iframe.
Yeah, as Arif mentioned that advantages are a bit more like when compared to a CSP policy, it's one of the best approach that we could use. Say that it loads the content in an iframe and it tries to like provide only the data that is required. Say that we are loading a lot of third-party JavaScripts which can be loaded inside an iframe and we can give access only to the required data so that we don't lose any data. So by this way, like it sets a lot of advantage in that particular perspective. Whereas like with this, like we can also get compliance for GDPR and CCTA. It's not only the control, but it is also one of the control. Yeah, but the biggest disadvantage is like advertisers hate it because advertisers tend to get more information as much as they can. But when you give the limited information for them, they might not be very interested with it. So some JS monitoring and remote monitoring and JS instrumentation is one of the key things here. So Dog and Reflectives were leaders in remote monitoring. For JS instrumentation, again JS Scrambler and Dog were some of the vendors that are there to help you with it. And plugins that we have used is like CSP Builder, Policy Generator, like CSP Tester. So these are Dog Scanner. These are all some of the plugins that we have used basically to develop some basic policies and then to see what are the inline JavaScripts that are being loaded in the page and also to validate the CSP policy. So a Dog scanner is something that's standard like a little bit aside from other plugins because it helps you with inventory of JavaScripts that are being loaded as well. So we have a small demo out there. So basically, like using that particular scanner, it will give you the inventory of JavaScripts and also like what JavaScript is accessing what data in your website, like that. So say that by running the scanner, we have tried to load bestbuy.com and then just pass the scanner there and see and look for the results. You could see that there is no CSP policy. And then what are all the scripts that are, it will use some basic CSP policy.
So let's say we have an outdated version of jQuery running, and how can the CSP prevent the attacks that can come from like outdated versions? And
I'm not so sure about that part, but then if we have, I'm not so sure about that part, but if you have included that in your script to call that jQuery, right? That one thing called inventory, you will see whether is that required or not. If not, then you will remove it. That's one way could help. Another way is the very first thing, we should never use an outdated jQuery in your application in the first place. And even if you are doing it, you need to make sure what that particular jQuery is doing. If it is doing an unintended activity, so in the last we have a framework build which you can use to ensure that all those three requirements are met. Right? So in that we would be scanning those particular jQuery and seeing what intended behavior they are performing. If let's say they are doing any malicious activity, then we'll remove from our inventory and will not whitelist them on the CSP policy in the first place.
like how we can fill the gap that CSP gives us.
Maybe so say that if something is being executed because of the outdated JavaScript in the client side, so probably when it tries to exfiltrate the data, if it tries to do some action which is like related with that particular context, then CSP will come into the play. Say that with the help of outdated jQuery, they try to load some external JavaScript, then the source will not be allowed in the CSP. Say that it tries to exfiltrate the content, so to the attacker's domain, whereas like attacker's domain might not be whitelisted in our CSP policy. So these are all the key catches that can be done and it can stop such kind of attacks.
See, it can never be a full-fledged solution.
Right.
I mean, that's a crux about everything, but that's true. We are
Yeah, and also to answer his question, I think the CSP basically gives or limits the exposure factor. So it basically limits the exposure to the particular domains which are whitelisted. And now being said that, one more thing that we need to include in the PCI 4.0 is about the integrity checking. The sub-resource integrity is also equally important apart from the CSP. So the sub-resource integrity needs to be included as part of the integrity checking. So whichever scripts those are loading in the browser, those needs to be also checked against some hashes or the salts that the scripts are not basically tampered against.
So we do have included that in our framework, but thank you for mentioning that. Yeah, so to be cut to short that it limit the exposure.
So I have one question from my side. So idea from an external perspective, like as an external attacker, I would need to actually need the access of that particular bucket of the third party in order to inject my payload. So at last, what I'm relying on, I mean there has been a lot of backend code, I'm relying on a third party where I'm not sure it could be hacked. And I think that could be the only reason how your website could be impacted. And I believe JS has no impact over the site. Let's say if I'm using very vulnerable JS, so I don't think it could be exploited in any way which could create an impact over my server, over my data. And apart from this, like the solution which I feel should be like we store the entire JS in our safe environment, which could be our CDN, that could be our S3 bucket, or that could be our Cloudflare CDN. So Cloudflare offers a really nice CDN and has like all these monitoring in place, which is like, and it's like free of cost, and on AWS you just have to pay 10% or any chance you are security engineer. Like I look after my security as well as my DevOps for the global.
So every security engineer wants that to be done. That's the safest way. And now you have the control over the code, what is being loaded. But
CSP never
but
all the
that's not an ideal solution with the company with the developers. They will not allow, or they might not, because again it's a headache for them, right? To load that, to control that, and what if they are not developing that code in the first place, right?
So that's something like, let's say if I specifically talk about jQuery, right? So jQuery has like very big impact over the functionalities that you run over your website. And every time jQuery is like being updated, you're gonna get a new path for it, new endpoint. So it will not gonna remain the same. So at last you will be using the old, and they have like 90% website I have seen which are running over old jQuery. And that's a really big concern as per the compliance practices and the controls.
Right, absolutely. So that's why we said that CSP is not full-fledged solution. It has its own pros and cons. And for that particular thing, which you were mentioning, you can use a third-party script to monitor your website to check whether it's doing anything intended or not. If not, then you can take a further action.
That's correct. And apart from this, like SRI is the new thing that has came recently with the hash.
Yeah.
So it actually protects
But
your
the issue with that, the moment if they updated any code in their JavaScript,
You have to update the hash.
That will make sense. So the solution for that is that you use your own S3 bucket or the CDN, which can like list all your traits which are being
absolutely, but then again you will be losing out the extra functionality coming up. Okay? The new functionality which they are trying to put that. So see, everything has its pros and cons. And the more you list it, the more safer you will be. But sorry, that's not. That's not how industry works. So when I was doing my I was giving an interview to my company. They said that we are enablers of development of a business. We don't want to restrict the business, although we want to stay. That's our best intention. But we have to change our approach. We cannot restrict them. So that's how it is.
Yeah. So we can do that, but all the updation and everything becomes harder.
But thank you so much for that question. Yeah, thank you sir for helping us. Next presentation we might call you.
Right. So you could see that the scanner is showing more details about the scripts that are being loaded, the contents that are being accessed. So due to the interesting time, I'm just like moving ahead directly to the framework. Yeah. I'll make it. I made it in the last week. This one. Okay. Sorry for yeah. So the framework what we have developed is with all the PCI controls that is really required. So we came up with CSP block mode policy, which actually monitors all the violations. Whatever the violations that are coming new, we have to handle that. We have to update the CSP policy. If it doesn't require, we can directly block it. Another one is inventory of JavaScripts, where you store all the URLs that are being loaded. You get the justification for why it is being loaded with the hashes. So, and the other thing is like whenever engineering team wants to like come up with a new functionality or so, or they want to update it, they have to make a request to the security team. Security team validates that and updates the inventory as well as the CSP policy. So that comes the implementation, the integrity part. So like we can take a couple of approaches. One is like passive approach, another one is like proactive approach. So proactive approach is something we call it as SRI. So we try to put the hashes for each of the JavaScripts that are being loaded. The headache here is like whenever something gets updated, you have to update the hash or else your JavaScript is not going to load. So like you have to be well aware of the script that is going to change so that like you can change it. If something goes wrong, your website will be hampered. So that is the reason like many of the organizations might not take up this particular step. They go for the passive approach. They run the scans like in some particular duration to generate the hash and then see whether something got modified or not. In terms of modification, the questions can be raised and can be answered. In terms to think like something malicious got happened or not. So by this way, like we can ensure that all your scripts are getting authorized and inventory of JavaScripts are being maintained and your like integrity is also maintained. So this is the framework that we have came up with to solve all the PCI 4.0 requirements.
And you can include this framework in your SDLC processes. So it will be much easier for your organization to go through a pipeline.
Yeah. So these are all some of the references that we have collected.
And did we say thank you to Google? Okay. So in one of the references it should be Google. And
yeah. strategy.